Okay, this video will do a summary, an overview on the Fourier series. Then after that, from this you understand everything, and then we can start to do questions. Okay, so what we're doing here is actually is actually complex Fourier series. So the definition is that let's say we have any function. So let's say we have a square wave. Okay, so let's say we have a square wave, and then how do we represent, because having a square wave like that is very tough to actually analyze things anyways, because engineers, they all feels that, let's say you have a complex shape, then you cannot have this type of, you cannot simulate it properly. Let's say you have maybe I use a pen, hold on. Did I do anything? Okay, anyway, so yeah, so apparently if we have a so-called a very weird shape, maybe we have, how do you represent this? Ta-da, right? So apparently one way is to use a lot of sine wave, a lot of sinusoidal wave. So let's say you have a square wave now. You represent it in terms of this form, this sine wave, or also this combination of other sine waves. So you add up together, you can actually form the shape of a square. So alternatively, you also can form the shape of a sawtooth wave, or triangle wave, or semicircle wave. So this is generally the meaning behind a complex Fourier series. So by name, the series itself says that if you were to add up a lot of things together, that means many waves. This is one wave, this is second wave, and then maybe another third wave, fourth wave, and fifth wave. You add all together, you can actually converge into the actual wave equation of the, or wave value of the square wave itself. So you can form the shape very easily. So this is generally what it actually means, and therefore this xt, okay, this xt is the function of the wave itself. And if you were to integrate the xt, you'll get the area under the graph. Okay, so this is the meaning behind all these things. And then when you are dealing with signals, definitely you are dealing with frequency. So this is the natural frequency equals to 2 pi over the period. So this is the period. So let's say if you have this sine wave, one period is from here to here. Okay, so there is, for the period wise, you need to take note of two things. For the period wise, if you have a wave that is from one point to another point, ends here, it is considered one period. It is considered one period. There can be also another form, which is double angle wave. Okay, and in this case, this is one period instead of, instead of this is one period, but now it's just like that. Okay, so these are the two forms of the natural frequency, I would say. So with that, let's go to the typical trend. So as I said earlier, the square wave, or whatever waves can in this equation, can be re-represented in terms of this series. We call it a Fourier series. So therefore, there is two types. We have CK and C0. Okay, so C0 is the average of the whole trend. Although I don't know how to represent it in a graphical way, but however, so the series of them is so what is C? Typically C0 is in the middle, C0, because when you sub in k equals to 0, everything E will becomes a 0, because you see k is as a variable. So therefore C0 is the overall thing, and then k equals to 1, k equals to 2, and minus 1, minus 2, and so forth. So this is the series, and then you just sum it up together, so eventually you'll get a thing. So therefore the equation for this series, so let's say ck is in using this formula 1 over the t, which is the 1 over the period, okay, and then you integrate across the whole area under the curve. So as I say, if you integrate ft, you're just integrating in the area under the curve. And then you divide by the period. So essentially you're trying to, you want to know one piece by one piece by one piece of the equation, okay, of this trend, okay, you want to get the average. So this is what it means. And yeah, so ck and c0 is actually the average of your own of their individual trend. So ck is the average of this trend, c0 is the average of this trend. So you're just summing out all. So in this case, you're just summing out all the averages of different case. And as I said earlier, c0, c1, c2, they are called on harmonic. Okay, meaning that this is the first harmonic, second harmonic, this is negative harmonic, negative second harmonic, and they are the same. They are multiple of each other. Okay, c2 is multiple of c1, c1 is multiple of 0, and so on and so forth. So these are the things. And apparently they have to be continuous, okay. And then another tools. So this is the toolkit that you really need, okay. This one and this one is the toolkit that you really need for the whole section. And then and this understanding later I'll go through. And then this is a very important tool, a very important tool, okay. It is ej theta equals to cosine theta plus j sine theta, and then if it's minus j theta is equals to this form. So this form can be re-represented in many forms, okay. So let's say if you add this plus this together, okay, is this one, okay, this is actually this, and then you add up together you get this one. And if you take this and minus this, you get this one. And then you do some algebraic manipulation, you'll get this one. Sorry, you just bring this 2 down and then you just get cosine theta. So this is a general concept. Later you'll see how it's being applied. And then ft over means area under the curve, okay, the graph itself, as I said earlier. And then spectrum of periodic signal. It is a very useful way for you to see whether which of the spectrum is, which of the harmonic, as I say, which of the harmonic thing is the most important. Typically in this case the ck is the most important one, which is the any ck, like, okay, maybe this is ck, some ck value which is the highest, and then t over tp is actually c0, okay, which is c0, because from what I know, tp is actually equals to ft, okay, the function of y function, okay. So function of sorry, it's actually this one, okay, sorry. So if you integrate the function t, you get tp, okay. You just so let's say you have a function, maybe this is the function, and then you integrate, you get a whole area over here, we call it tp, so this is called tp. And then you divide it by across the period. This is the period, right? So you divide it across the period, you get one piece of it, you get average lah, I would say. So apparently this is the c0, okay. Let alone that we do not have the e minus j k w omega t, because k is 0 in this case lah, c0. So therefore let me destroy this first. So therefore t over tp is actually here, which is insignificant compared to some ck over here. So as from here you can actually see the co-relationship between the k's themselves, okay. So this is how it is. And then yeah, and type 1, okay. So now let's zoom out, zoom in zoom into the types of problems. Okay, so the typical problem, the type 1 problem is the very simple one, does which only reflects on this equation only. So apparently it's just some function that represent this square wave or sawtooth wave or whatever. Multiplied by this root over here. As you can see, this is always multiplied. So some function multiplied by e, okay, and then you integrate them. So type 1 is exactly the same as this. Okay, type 1 is exactly the same as this. Okay, so type 2 is a little different. It's in terms of integration by parts. So let's say your function is in terms of t now, okay? Your function is in terms of t now, which is previously the function was in terms of the function times the e minus j omega t, right? Now if the function is multiplied with t that contains t, then you have to do integration by parts. Okay, this is the general concept that is lah, okay? I think I omega. Okay. So apparently the third one is actually deals with the cosine and sine. So a typical question would be, it's very different, okay? It's different from this two. Okay, now the function itself can be because we didn't evaluate, so the function itself is actually 1, 2, or some easy functions. Okay. However, when type 3 comes in, the xt now, the function itself is actually in terms of cosine and sine. So therefore, if you were to use the manipulation techniques, which is the Euler's, this is actually called the Euler's equation. So you do some subin, and then eventually you solve for cosine and sine. Sorry. And then you do it in terms of e. You change it into e minus. Okay, you change it into this form, and then you just sub it in, and then you multiply. Okay, you just combine this thing, and then you do your stuff. Your stuffs. Okay. So the stuffs I'll explain in the next few videos. Hopefully it will be fast and clear. And then so after you okay, so now after, so in this case we already know the different type. Now we deal with the omega, okay? We know that omega naught equals to 2 pi over t. Omega naught is equals to 2 pi over t. Therefore we can straight away solve for the omega naught, right? So omega naught is 2 pi over some period. You just divide and then you just get. Okay. So typically this is the natural frequency, but however if you are given any other frequency, then you use that frequency. Okay. And then so now this is a trend. This is a trend to set to see whether it's the positive or is it negative, because you want to create a series, right? Remember previously we say that the Fourier series is a combination of many c. So it's c0 plus c1 plus c2, and then this is minus 1, minus 2, etc. Okay. But however, there may be minus sign, there may be plus sign, and then this may be minus sign again, that of thing. So how do you determine this? So therefore, to determine this, one method is to have this, because after you sub in the omega d, okay, if you were to take a close look in the equation itself, maybe I should go in here. Yeah, it's e minus jk omega t. Okay, so omega, if omega is some value, then minus jkt is already is somewhat okay, sorry, if omega, hold on, yeah. Oh, okay. So apparently jk omega t, it does bring the t upwards, you get 2 pi. So everything, it depends on the situation of the question lah. I just remember this is the thing, and then you can have some manipulation. So apparently t multiplied by omega equals to 2 pi. So it's like a general formula for this is a general formula for everything. So let's say if it's minus j pi, let's take it as if omega is um let's say the period is, hold on let's say this is not 2 pi. Okay, let's say omega naught times t equals not 2 pi but rather pi, then um then you have this form. Okay, so what generally it is let's say after you submit all your omega t and whatever thing you left, yeah, and k, you're left with this portion. Okay, this represent minus 1. Okay, what I mean is, let's say if you have that, as I said earlier, minus j k omega t, right? So typically the type of question when you tackle is straight away you find omega and t, and then you find uh your k also. So end up you only have uh oh okay, just sub in the omega and then you sub in the k, and then this is just e minus gt, and t itself can be pi times 2 pi or whatever. So yeah, maybe I pause the video a while. Yeah, I'll see how. Okay, after reading, I realized okay. So let's say let's similarly we take the e minus jk omega t. Okay, so let's take omega t. I mean this is the t. I mean the period. Omega times the period equals to 2 pi. So with the subplane equals to 2 pi. So this portion becomes 2 pi. Okay, and then minus jk 2 pi can be represented in terms of the Euler's formula. So E minus J theta. So if theta is 2 pi, then you just sub in the theta. So this is what it is. So EJK theta 2 pi, just sub in. And then cosine 2 pi is actually 1. Cosine 2 pi is 0, I think. Yeah, 0. So cosine 0 equals to 1 plus sine 0 is definitely 0 ma. So definitely this is 1. So this is like how do I say, a toolbox for you to review. I mean a checklist lah. Okay, so let's say if you have this trend e minus j pi, then you use minus 1. If it's minus j pi k is minus 1 k, and then if minus j 2 pi k equals to 1. So what it means for the other two, okay, let's try that. Okay, so if it's e minus j 2 pi k, which is this, then is equals to 1, right? Or however, if it's minus j pi k, so let's try if it's minus j pi k is equals to cosine then minus pi plus j sine 2 pi. I mean minus pi is equals to minus 1, right? Or however, whatever k you're dealing, you change the thing over here. Because if k is actually negative, then this will become positive. If k is equal to 2, then you square it, it becomes 1. If it's 3, then you become minus 1 and back again. So this is why there is a k in front. But however, for this case, if whatever k you are, you square, you cube, you negative, whatever you get, you still get back the 1. Okay, so this is the general concept. And then for e minus j pi is when k equals to 1. Okay, so when k equals to 1 is e minus j pi, and then you just get, the same thing. So this set a very good checklist for you to actually review on. And then let me see. So the next portion, I hope this clears out everything for here. And then next is the setting equation of the function, our given function. So let's say if you are given a graph like that, and you're not given any function, okay? Because typically the graph is the function itself. So apparently what it means is that let's take that this y-axis is the amplitude, and then this is the time. So the square is just the amplitude. Okay, actually my equation is wrong. So apparently this should be um sorry half t, and what I mean later you'll know what I mean. Okay. I may be wrong lah, but I think it should be correct. So apparently as I said earlier, this portion is the period, right? So apparently if you are taking one part of this, it's actually um because you're trying to find the area under the curve, right? And the equation is given by what the equation is given by is actually a multiplied by half t. Okay, so you get the area under the curve already. And then for sine, it is the trend is actually sine t for sine theta lah. Okay, it should be sine theta, some angles lah. Okay, and then this is some mt plus c because this is a linear one. This portion is linear. So mt plus c equals to a because the gradient multiplied by the t, the time function, plus some constant equals to the y, mx plus c equals to y. This is, although this is not very clear explained, but I think it's pretty cool. And then only the last thing is that take note that if you are dealing with one positive and then it comes out to negative, we have to use two type of definite integral. Okay, because from a to b is the positive, but however from b to c it becomes negative. So when you plus up together, it becomes 0. So this is the thing. So you have to be careful when you do this of when you have oscillation, instead of everything is upwards like that. Okay, like this lah. Okay, instead of this. So just to give you an overall summary is that we talk about the definition, and then we talk about why we want to use this equation, why we use Fourier series, and then the typical trend of the Fourier series, and the very usefulness of the Euler's equation, and then the integration of our equation of the graph gives us the area under the graph, and then the spectrum is to help us to visualize which are the most important averages of the whole equations, which is the most important, the highest level is the most important one, okay. And then the different type of Fourier series questions, that is, yeah. And then the knowing the trend to know which is the plus, which is minus, this is how it is. And then setting the equations of our function. I think this is not, I believe that this is not the equation for a square wave. Okay, so that's all, and see you next video.